Okay, greetings to everyone. So today's class we are going to discuss about the problem related to plastic analysis. Okay, so today we will solve this university question. Okay, so a two-span continuous beam of uniform section loaded with ultimate loads as shown in figure. Determine the required plastic moment of resistance. So here they have given that support, one support is fixed support and one is continuous and another one is hinged support. Okay. So the load is acting 10 kilonewton at a distance of 2 meter from the left hand support. Then the BC is loaded with UDL 30, the load intensity of 30 kilonewton per meter and the span of 4 meter. So for this, we are going to calculate the plastic moment of resistance. Okay. Now let us move on to the solution part. First, we should draw the diagram. Okay. So yesterday we have discussed one problem. It is a kind of similar problem. Okay. So 4 meter, here it is 10 kilonewton is acting. Here another 10 kilonewton is acting. So the distance is 2 meter from the support. And the UDL we can have, the intensity of UDL is 30 kilonewton per meter. So this is our given data. Now I'm going to give the support designation A, B, C, D, E, and at the mid I'm going to give as F. Okay. Now let us go on to the solution part. Okay. First of all, degree of indeterminacy. Degree of indeterminacy. Okay. So R is equal to number of reaction plus end moments minus 2. Okay, so this is for only beam section. This formula is for beam. This is for beam section. Okay, so here number of reaction, number of vertical reaction. Okay, number of vertical reaction. So 1, 2 and 3. So 3 plus end moment. So here we can have fixed support. So fixed support have an end moment. Okay. So 1 minus 2. So it becomes R value is equal to 2. Okay. Then next we should move on to number of possible hinges. Number of possible hinges. So as earlier we discussed that the possible hinges will be available. Okay, plastic hinges will be available at, first one is fixed support, second one is continuous support, and third one is under the loads. Okay, So as per the statement, how many plastic hinges are available? First one is fixed support. So here one is available. Okay. And continuous support. So this one is continuous support. So here one is available. Okay. Then under the load, one, three. Sorry. Here one is available. So total 1, 2, 3, 4 and 5 available. Okay. So that we are going to. So our fixed support one, continuous support one, there are three loads. So each three. So 5 is the number of possible plastic hinge. Okay. Next, number of mechanism. So number of mechanism, how much, what it is means, the formula is number of, this one we are going to take it as n. So number of plastic hinge minus r. So n value is equal to 5 minus r value is equal to 2, so that number of possible mechanism is 3. Okay, there are 3 mechanism is available. So that 3 mechanism is for corresponding to their loads. Okay, so first I will draw the mechanism 1 diagram. So mechanism 1 is related to the load acting at point D. Okay, with respect to span AB. Okay, load acting at point D, span AB. Okay, so first I will draw the diagram. Ten kilonewton, 10 kilonewton. Okay, 2 meter, 2 meter, 2 meter. This is A, this is B, this is D and E. Okay, then after okay, this much only. Now I will draw the mechanism diagram. Okay, so first of all, number of plastic hinges. So this is at support A is fixed, so we can have. Okay, now similarly support B we can have because of continuous support. Okay, then under the load D we have to take. Okay, so under the load D we can have. So because of this load we can have another plastic hinges here. Okay, so corresponding to this slope, here it is theta. Okay, the same theta is to be available here. Okay, now and this slope is not equal, so we are going to take this one as theta 1. Since the span is, here it is 2 theta, but from here to here it is 4 theta 1. Okay, so that's why it is not equal, I said. Okay, so this is theta 1. Okay, now because of load we can have another plastic hinge MP here, MP and MP. So this is the load 10 kilonewton here and another load 10 kilonewton here. So this height is nothing but 2 theta 1. Okay, now I have to change or convert theta 1 in terms of theta. For that I am going to use this relation. Okay, so 2 theta is equal to 4 theta 1. Therefore theta 1 is equal to 2 by 4 into theta, that is equal to theta 1 is equal to 0.5 times of theta. This is for the mechanism 1. Okay. Next I should move for mechanism 2, that is the load under E in the span AB. Okay. Next, mechanism 2. Mechanism 2, that is the load at E in the span AB. So here as it is 10 kilonewton, and here it is 10 kilonewton, 2 meter, 2 meter and 2 meter. So A, B, D and E. Okay. Now with respect to this diagram, what are all the mechanism, this beam mechanism that I am going to draw now. So now because of load acting at point E, okay. So here what is the deflection? So this is fixed support. So here I can have plastic moment MP, and this is continuous support. Next to that I can have one support, okay, C. So that I can have the plastic movement here also, and here the slope is theta. Okay. So the span is 2 meter plus 2 meter is 4 meters. So 4 theta here. Okay. And from here to here, this slope is different when comparing with that one. So I'm going to take it as theta 1. So this distance is 2 theta 1 is equal to 2 theta 1. Okay. So under the load, I can have one plastic hinge. So it becomes theta and theta 1. So here also MP. Okay. Now under the load D, the deflection is 2 into theta. Okay. Here under the load, the deflection is 4 theta. Okay. So this is related to mechanism 2. Okay. Now for the span AB. Next to another mechanism, that is three mechanism is available. Another mechanism with respect to the span B to C. Okay. That I am going to draw now. So span mechanism 3. Mechanism 3. The load acting on the span BC of UDL 30 kilonewton per meter. Okay. So here it is continuous edge. Okay. Here we can have span. So B, here it is C, and here we can have the load 30 kilonewton per meter. So the span length is 4 meter. Okay. Now with respect to this mechanism, the diagram will be, so if it is UDL, I am going to draw like a this place I am going to say it is F. Okay, no, midspan of the span. Okay. So this is continuous support. So we can have plastic moment of MP, and this is end support, that too hinged. So we does not have plastic hinge. So it will be denoted in the empty circle. Okay. And under the load, we can have plastic hinges. So I'm going to have MP here. Now, because of this position, the slope is equal to theta. The UDL means both the side are same, theta. Okay. So this is also theta and this is also theta. And the height here, it is 2 theta since half of the span. So here it is 2 meter and here it is 2 meter. So it becomes 2 theta. Now the load is acting entirely 30 kilonewton per meter. Okay. So these three are the mechanism now. So with respect to this mechanism, what is the plastic movement that we are going to discuss now? Okay. So let us move on to the plastic movement. Okay. So plastic movement for span AB. Okay. As per virtual work method, we know that internal work done is equal to external work done. Okay. So internal work done is because of plastic hinges. Okay. So first one mp theta here. Second one mp into theta plus theta 1 plus mp into theta plus theta 1 plus at support B mp theta 1. So theta 1 is equal to 0.5 times of theta that we are going to fill up right now plus mp into theta plus zero point 0.5 theta plus mp into zero point 0.5 theta. So here it is mp theta, here it is 1.5 mp theta, here it is 0.5 mp theta. So total 2 plus 1, 3 mp theta. Similarly, external work done is equal to because of external load. Okay. So first under point D, 10 into 2 theta. So 10 into 2 theta. Next plus 10 into 2 theta 1. 10 into 2 theta 1. So 10 into 2 theta plus 10 into 2 theta 1. Theta 1 we are going to write in terms of theta. So 2 into zero point 0.5 theta. So it becomes 10 into 2 theta plus 10 into zero point 0.5 into 2 becomes 1. Okay. So theta. So total value is 10 into 2, 20, 20 theta plus 10 theta, 30 theta. Okay, therefore MP for span AB is equal to 30 theta divided by 3 theta. So theta theta get cancelled. So it becomes MP is equal to 10 kilonewton meter. Okay, this is for the span AB. Next, we should move for the span AB under the load of E. Okay, so here we have to convert this theta 1 in terms of theta. Okay, so 4 theta is equal to 2 theta 1. Therefore, theta 1 is equal to 4 divided by 2 into theta. Theta 1 becomes 2 theta now. Okay, now let us move on to the plastic movement. So plastic movement of the section of the span AB under the load E. Okay, so as per virtual work method, internal work done is equal to external work done. Okay, so internal work done should be because of these plastic hinges. So at support A, mp theta, then under the load mp into theta plus theta 1, then at support B is equal to mp theta. Now, sorry, mp theta 1. So theta 1 I am going to change in terms of theta. Okay, so theta plus 2 theta plus mp into 2 theta. So it becomes mp theta plus here it is 3 theta. So 3 mp theta plus here it is 2 mp theta. So 5 plus 1, 6 mp theta left hand side. Now right hand side, that is external work done because of load. Okay, so 10 into 2 theta. This is load under the point D. Next load under point E is 10 into 4 theta. So it becomes 20 theta plus 40 theta. So 20 plus 40, 60 theta. So 60 theta is the value. Therefore, MP is equal to 60 theta divided by 6 theta. So theta theta get cancelled. Therefore, MP becomes 10 kilonewton meter. Okay, so this is with respect to the span AB. Next, we can move on to the span BC, and because of the load. So here the theta will be uniform since the slope is uniform in the both side. Okay, now as per virtual work method, the internal work done is equal to external work done. Okay, so internal work done is equal to, because of plastic hinges, so at B and at F is available, C it is 0. Okay, because of this support condition. Okay, so now we should move on to this condition. So MP into theta plus, next one is here, MP into theta plus theta plus 0. So MP theta plus MP into 2 theta. It becomes 2 MP theta plus MP theta. So 3 MP theta is our internal work done. Next, right hand side, due to external work. Okay, external load. So if it is external load is UDL, we have to take load into area. Okay, so EWD, external work done, is equal to, if it is UDL, then load intensity into area we have to use. If it is point load, then we should go for EWD is equal to load into deflection. Okay, so now load into area. So load 30 into area, half into breadth 4 meter into height 2 theta. So 2 into 2, 4. So 30 into 4 theta. So 120 theta. Therefore, MP is equal to 120 theta divided by 3 theta. Theta theta gets cancelled. So 4. So MP is equal to 40 kilonewton meter. Now MP for span AB at load E is equal to, okay, na, 10 kilonewton meter, and MP for the span AB under the load E is equal to, here it is at D, here it is at E, that is also 10 kilonewton meter. Next, MP at span BC, okay, because of UDL it is 40 kilonewton meter. They, in the given data, they are asking plastic movement, required plastic movement. Okay, so required plastic movement or fully plastic movement is equal to maximum of above values. So maximum of above values. So if I am going to consider that MP is equal to 40 kilonewton meter is the required plastic movement for the given beam and for the given loading condition. Thank you.